Hello, everybody. Welcome to this webinar. I'm Fernanda Schmidt. I'm product specialist at NOVUS, and our webinar team today is composed by our product manager, Fabio Pilma, Jose Souza, which is from technical support, and Marco Sigman, which is key account executive of the region of North America. Okay, first of all, I would like to thank all of you to invest your time in today's webinar. HART is simpler than it seems. The idea is not to be too long, but to pass the right message in order to approach the customers. This webinar is being recorded and will be available to all attendants that couldn't watch on live. You will be able to make questions by written in the tool, and we will make some voluntary survey during the presentation. Questions can be made at any time of this webinar. You can access the Q&A icon, and then you can write the question. You can choose to be identified or to be anonymous in the question. All questions will be recorded, so don't worry if you don't have the answer right now. It will remain in the database and we'll see it later. This is our agenda for this presentation. So, we will talk about HART history in the industry. After that, we will make an overview of the verticals of HART devices. And we will go deeper on applications and HART technology background too. At the end of the webinar, we'll have time to answer the most common written questions. But if some question remains open, please, you can access your NOVUS account executive. Anyway, we will gather all the questions and send the answers to all attendants in a questions and answers document. Industrial communication enables the transfer of data, commands, and other information to streamline process control and factory automation. During the last decades, several industrial protocols were developed by the manufacturers to meet the communication needs for plant control and management. The HART protocol was originally developed by Rosemount Inc. in the middle 80s as a proprietary protocol. It evolved into HART in 1986, and it was made an open protocol since then, when it became an IEC standard. So, the HART is a hybrid analog plus digital open protocol. Its most notable advantage is that it can communicate over legacy 4 to 10 milliamps analog instrumentation current loops, sharing the pair of wires used by the analog-only host systems, enabling two-way digital communication with smart microprocessor-based field devices. Due to the huge installation base of 4 to 20 milliamp systems around the world, the HART protocol became one of the most popular industrial protocols today. HART protocol has made a good transition for users who wished to use the legacy 4 to 20 milliamp signals but wanted to implement a smart protocol. The HART communication protocol is today a global standard for smart process instrumentation. Now, I'd like to run a poll and ask your participation to answer it about the HART knowledge of our audience today. I'm launching the poll. So the question is, have you worked with HART devices? I don't work with HART devices. I don't know what it is. I've heard but never worked with HART. Yes, but I don't get much demand. Yes, in some opportunities. And the last one, yes, I'm in this market. Okay, we're receiving your answers. Just wait a couple of seconds more. Okay. Thank you for your answers. Getting back to the presentation, the industry has been using 4 to 20 milliamps and HART over 20 years. So There is a wealth of experience to draw on and a very well-defined set of tools and processes that have been developed by HART devices. That means simplicity. HART is inexpensive and easy to use. It makes use of existing wiring plants, and cost and installed base will keep it dominant for a long time. The ARC Advisory Group reports about half the worldwide installed base of process measurement and control devices are HART-enabled. The global installed base of HART-enabled devices is the largest of all communication protocols, more than 40 million devices worldwide. There is no other protocol that has the massive installed base, is open to all vendors, has proven worldwide end-user support, and continues to get updates and unilateral support from nearly all mainstream device manufacturers. For these reasons, HART will continue to retain its leadership role. The chart below shows the market share for DIN rail temperature transmitters. NOVUS is currently one of the players on this market, with versions not isolated and isolated. Now, NOVUS already released the HART versions, DIN rail and head mount. Moreover, the other chart shows this market growing, which means there are still many opportunities to be caught. Regarding revenue with temperature transmitters, getting the price list of NOVUS portfolio, in which there are not isolated, and HART devices, DIN rail and head mount, the not isolated family is the entry level, the economic level. Let's assume the price list is X dollars. The isolated family, the mid-level, has price list 2X dollars. Finally, for the HART family, the market base price list 4X dollars. So, as the HART devices market is more demanding on robustness, reliability, interoperability, and two-way digital communication, beyond other benefits, it has more added value requirements, and the market pays more for it. It is a good market to explore, considering the demand, the market size, and the growing trend. Now, I will run our second poll about the verticals of HART. In which verticals do you see opportunities for HART devices? Steel and metallurgy, mining, oil and gas, chemical industry, pulp and paper, and others. Please be free to answer our poll, simple survey about the market for HART devices. Okay, thank you again for your participation. Continuing the presentation now, we'd like to talk about the verticals. HART is well established in many process industry applications in verticals such as petroleum and gas industry, chemical, cement, mining, pulp and paper, and other industries. Users around the world get valuable process and diagnostic information from their systems to enable them to avoid unplanned shutdowns, improve plant reliability and availability, lower maintenance costs, and diagnose potential device problems from anywhere within their enterprise system. Beyond that, HART standard ensures interoperability and secures the investment to the freedom of having a wide range of suppliers to choose products from. DuPont, a chemical industry, needed a better way to test safety interlock control valves during plant operations. It was added intermediate instrumentation to extract relevant data from the plant's heart instruments. It was used partial valve stroke testing of emergency shutdown valves during normal operations for fewer and shorter shutdowns. Over 100 control valves equipped with heart loop monitors were installed. So, valve safety interlock testing would be a less labor-intensive and cumbersome operation. BP Canada Energy achieves accuracy between 0.1 and 0.2% in custody transfer of oil as it changes ownership road to and from sites across Canada's oil-rich Alberta province to meet contractual requirements. In roughly a decade, a majority of 600 transmitters were upgraded with HART devices and flow computers, handling up to 4 transmitters each. HART communication provided an all-digital data path, eliminated the need for conversion when analog to digital conversions were resulting in metering inaccuracies. Transmitters were also upgraded for greater accuracy. Cebra's Crystal Plano seeks to improve plant maintenance by increasing volume and quality of data received from equipment and to integrate data from HART-enabled devices in conjunction with data from a foundation field bus network in a single plant asset management software system. The plant gained access to data from multiple protocols in an integrated, web-enabled asset management application system. Smart valve positioning diagnostics further improved in-loop operation and downtime avoidance. HART technology arises from hard times, when field technicians faced huge difficulty to manage all the diagnostic tools and software for devices from diverse manufacturers that needed field maintenance. Just imagine a plant with hundreds of field devices from different manufacturers. How many tools and software the instrumentation team needs to manage? Changing this scenario by a HART handheld tool sounds like a big time and resource saver. As we know, time is money, and the diagnostic capabilities of HART-enabled field devices minimize the time required to identify the source of a problem. There is no need to take out the device from the field to run a diagnosis. Consequently, the trips to the field are reduced or eliminated. The easy and fast diagnosis allow quick correction, reducing downtime, thus raising plant efficiency. Now, let's talk a little bit more about the HART technical features. HART uses FSK, frequency shift queuing, modulation technique called Bell 202 standard, to superimpose a digital signal on top of the 420 milliamps. Using this technology gives the operator easy identification of the field device by its tag and allows to verify all operational parameters. The HART protocol allows two masters, primary and secondary, to communicate with slave devices and provide additional operational flexibility. A permanently connected host system can be used simultaneously while a handheld terminal or PC controller is communicating with the field device. The HART protocol enables hosts to easily access and communicate the most common parameters used in field devices. Considering that, the instrumentation technician has no doubt if the diagnosis will be done. They are sure. Established in 1993, the original HART Foundation, now Fieldcom Group, is a technology owner and standard-setting body for the HART communication protocol. They ensure field devices interoperability through a rigorous device testing procedure and a registration program. NOVUS since January is a Fieldcom Group member and has two registered devices, TX ISO Rail HART and TX ISO Block HART, both with HART version 7. These devices are fully compatible with HART devices worldwide and are compatible with HART versions 5 up to 7. Beyond the benefits of HART features, these devices, which are temperature transmitters, are galvanic isolated, 1.5 kilovolts RMS between input and output, and have high accuracy measurement. The HART command set provides uniform and consistent communication for all field devices. The command set includes three classes: universal, common practice, and device-specific. Regarding some common practice commands, we can show some interesting features. DAMP is a filter that changes the transmitter response time to smooth variations in the output rate caused by rapid changes in input. For example, consider a temperature transmitter. If the temperature undergoes a step change from 0 to 10 degrees and the damping is set to 5 seconds, the transmitter calculates and reports a new reading every 500 milliseconds using the damping equation. At 5 seconds, the transmitter output will be 6.3 degrees, or 63% of the input change, and the output continues to approach the input curve according to the filter algorithm. Lock and write protection. Lock is a command that temporarily locks a device, preventing any parameter change from a local panel or a secondary master. In this case, the HART primary master has exclusive access when configuring or calibrating the field device. The write protection, on the other hand, is a device-specific command that puts the field device in a reading state, which means no write commands accepted. Only reading commands are effectively executed. Input and output trim is a command that can be sent to device to perform adjustments or calibrations in input and output separately. The adjustments are of gain and offset on the initial and endpoint. A commissioning helper is the loop integrity feature. The loop could be checked by to set the field device analog output to a preset value. In the NOVUS transmitter's case, 4 milliamps. The analog loop diagnosis is so much easier this way. Besides the HART features, NOVUS temperature transmitters are compatible with 12 different sensors, thermocouples J, K, T, R, S, N, E, and B, RTDs PT100 and PT1000, NTC thermistor, and millivolt input. The typical accuracy is less than 0.08% of span in most sensors. As you can see on the accuracy table, it has two different values for each type of sensor. When the temperature value is read digitally by HART, the error of the current loop could be discounted. In other words, it has more accuracy in the measurement process. NOVUS transmitters, TX ISO Rail HART and TX ISO Block HART, are NAMUR and E43 compliant. The sensor failure alarm establishes the output current behavior when the transmitter indicates a failure. Downscale. Output current goes to lower than 3.6 milliamps, typically used for refrigeration, and upscale. Output current goes to greater than 21.5 milliamps, typically used for heating. To these transmitters, the operating conditionings are temperature from -40 to 85 Celsius degrees, or -40 to 185 Fahrenheit degrees, and relative humidity from 0 to 90%. The installation of a HART device is the same as any other 4 to 20 milliamps device. The only difference is that communication is made over the current loop, requiring no additional or special cables. The same cable that provides power will also provide access to HART device settings. For the configuration and maintenance of HART device, you only need a device that reads the HART protocol. It can be a modem or a handheld. This equipment has the ability to read any HART device, regardless of manufacturer. There is no need to carry various types of maintenance tools, either a resistor that the field technician can carry with the modem, or it may already be installed directly on the HART device, just awaiting for the modem connection. To enable the communication, just plug the HART modem with the resistor in series with the current loop. Either positive or negative side will work. With just the simple connection, the technician will have access to all device configurations. NOVUS offers proprietary free software, the TX-Config2, for configuration and diagnosis of NOVUS HART devices. Its user-friendly interface has the necessary configuration options, which are easy to set. Just selecting the modem's COM port and software will automatically recognize the device. When reading the device, the technician will already have access to the configuration, as well being able to monitor the parameters in real time at both temperature and 4 to 20 milliamps output, facilitating configuration changes and preventive maintenance. Now I would like to run our last poll, and this poll will be shared with you about the highlights of HART features. What are the highlights you see on HART devices? The first one is field diagnostics without removing the device from the plant. The second one, easy to upgrade 4 to 20 milliamps legacy systems for digital communication. Can be used or replaced on HART system of any brand. Proven robustness attested by FieldCom Group. Digitally monitor without need for active current loop. Or the last one, I don't see highlights. You just wait a few seconds. Okay, we're receiving more answers. Okay, just a few seconds more to end the polling. Okay, I'm finishing the poll right now, and I will share the results with you. Okay, so we have 63% in two answers, field diagnostics without removing the field device from the plant, and the other digitally monitor without need for active current loop. And here 50% to other two questions. Easy to upgrade 4 to 20 milliamps legacy systems for digital communication and can be used or replaced on HART system of any brand. So we really appreciate your answers. Thank you again. So to facilitate access and hands-on training with HART technology, we have created a HART starter kit, which comes with a NOVUS HART modem, the TX config HART, two transmitters, the TX isoblock HART and TX isorail HART, two NTC sensors, an FTR power supply, along with a quick guide to precisely orient how to set up and test the HART features. This quick guide shows how, in 5 simple steps, devices can be configured. In addition, there is a video tutorial that guides how to download the TXConfig2 software, how to set up the HART network, and finish applying new settings to the TX isoblock HART or TX isorail HART. Here's an example. Okay, now I would like to ask to my colleagues the most common written questions. We have answers, questions and answers here, guys.
Yeah, we have one question right here about the HART. Does HART communicates using a 420 milliamp signal? The HART protocol uses two communication signals in the same current loop cable pair, the 420 milliamps analog signal and the superimposed digital signal. The 420 milliamps signal transmits the main measured value, while the digital signal contains information from the HART device, such as status, diagnosis, and configuration values.
I have another one here. Question is HART one-way communication? No. HART has two-way communications, but it is half duplex. That is, it communicates one way at a time to send and to receive data through the digital signal.
Okay, we have another one right here. What are the DD files in the HART? It is the file that defines the description of the HART device parameters. The communication diagnostic software interprets this DD file and determines how the device appears on the application and what are the parameters available.
I have another one. Why do I need to use a resistor? And the answer is a minimum current loop impedance is required before the HART signal can be picked up by a modem or handheld. The resistor inserted in the loop generates a minimum required voltage drop that allows communication for the HART modem. Okay.
There is one more. Should I only use a 250 ohms resistor? Not necessary. The minimum impedance from the HART device is 250 ohms, and the maximum is 1,208 ohms for a power range between 30.8 and 36 volts.
Another question, how should the resistor be connected to the current loop? The resistor should be connected in series on the loop, regardless of its polarity or position in the loop.
Okay, now one about our products. What's the difference between the TX isorail HART and TX isoblock HART? They are basically the same device. The difference is the TX isoblock HART is suitable for mounting protection heads, and the TX isorail HART is for mounting on DIN rails.
Okay, another question. Can I communicate with this device through USB? Yes, using the modem TXConfig HART, it uses USB micro B standard.
Okay, one more. Novus use the HART 7 or HART 5 protocol. We use the HART 7 protocol, but it's compatible with the HART 6 and the HART 5 protocol.
Okay, thank you guys. And just a reminder about the HART starter kit. This starter kit can be taken to any customer for a demonstration on new or legacy 420 milliamps applications, and is now available with a special price. So please check with your key account executive about the price for this starter kit. Okay, I'd like to thank all of you for your participation today, and see you in our next webinar. Bye-bye.